Hello everybody. So today we will build this amazing map in Godot. Now this map is built entirely using cubes and cylinders, but you will be able to add other geometries also. This is really simple. Now the really fun part of the map is that this map is not a static map. It is a map randomizer. So if I click on the randomize button at the top left corner, every time you will see a new layout is generating. We are redrawing the map entirely. Now I will also give you a capsule to move around and let's see how we can build this amazing thing today. So make sure to give this video a like and let's open Godot. Now in Godot, I will start by creating a new 3D scene. I will rename it to 3D geometry map. Let's also save this in the scenes folder. And now if we compare with 2D, in 2D we make maps using tiles. However, in 3D we have to use mesh. There is no such thing as tiles. So what I will do is I will import a mesh instance 3D, and here I have an empty mesh. I can select a mesh here. For example, I will select a box mesh. Now using these arrows, I can keep the box here. Now apart from the box, I also want cylinders. So another mesh instance 3D, and this time I will select the cylinder, and I have a cylinder. Now, apart from moving using the arrows here, I also have the scale tool, and using this, we can actually increase the size of the cylinder. And there is a rotate tool also for rotation if required. So I think cylinder rotation is not really required. So yeah, let me just keep it above. Now, if you think carefully in our map, apart from boxes and cylinders, we also had one more thing, and that is a platform where everything was standing on. So for that, we will need another mesh, and let's select a plane this time. And we got a plane. So let's create a much bigger plane. So we'll take the scale tool. And now if I just click on the square instead of the block, so we can scale in both directions. We can scale even further. And let's keep little bit down so that everything can stand on it. So in this way, we can create lots of like lots of meshes and one 3D map like this. But this is a very tedious process. There can be 20 boxes and 30 cylinders, and we should not be keeping them by hand. So what we should be doing instead is use a script to do our job. So in our 3D geometry map, I will click on attach a script, and I will save a script inside the scripts folder, and let's name it 3D geometry map, and let's create a script. So our script extends node 3D, which is fine. And now I will start by defining few variables. So first I will define the map size. This will be of the type vector 2. Although this is 3D, this is basically the horizontal span of the map. That is what we are trying to define. So let me give 20, 20. Then we also need how many boxes and how many cylinders. We need to set a number for them. So num boxes we will give, let's say, 15, and then for the number of cylinders, let's give 10. Now we will also set some scale for our maps. So export where minimum scale will be, let's say, 0.5, and we will also set a maximum scale. Now in case you're wondering what the scale will do, so whenever we are importing some mesh, for example, boxes or cylinders, we don't want them to be of the same size always. Uh, what I want is they should vary in their size. So that is what this minimum and maximum scale is for. So they may be half as small or twice as big. Basically, that is what we want. Now here there is an error because we also need to set a var. Now, lastly, to create and store our map, we will create a map container, and this will be of the type Node 3D. Basically, our map, instead of like making by hand, we are making by script. So it will definitely be of Node 3D only. Now, whenever we are starting our game, we need to do a randomize, and then in our map container, we need to create a node 3D instance. So node 3d.new. Now let's give a name also for the map container. So map container dot name should be, let's give it a 3D map, and let's add a child called map container. So what this is doing is basically in our 3D geometry map where the script is attached, it is adding another child called the map container, which is another node 3D. So within a node 3D, we are adding another node 3D. You can compare this with a node 2D where we add a tile map layer. Now here there is no tile map layer, so we will be adding another node 3D only, which is our map container. Now, after adding the map container, we generally have to do two things. One is create the floor, which is our plane, and then generate the map, which is basically generate boxes and cylinders. Let's name it generate map. Then we will also drop our player and those things. So we will see how we can do that. One more thing is remaining actually, and that is a setup of our camera. So we will need to define these functions. Now, right now, everything will throw an error because we need these functions. So create floor, one function, then let's add another function, func generate map. This will be another function, and then we will have func setup camera and pass. Now, before writing these functions, there is one more thing that I want to show you, and that is right now um, we have few things here. So what happens if I click on the run scene button? Do we get anything or not? So we can see that we are not getting anything, and this is because we don't have a camera. So whenever we have a camera in the scene, only then we will be able to see what are the things present in the scene. So we will need a camera, and this is true for our 2D also. So in the 2D also, there is a camera that stands behind the player, like that follows the player. So something similar we need for our 3D map also. So let's start by setting up our camera. So let me remove the pass. Let me select camera as camera 3D dot new. Let's give the camera a name of camera, and camera position should be um, let's give the camera a position at the center of our map. So vector 3 0 comma map size dot x by 2 comma map size dot y by 2. Now we also have to set the rotation. So rotation degrees will be vector 3 minus 45 0 comma 0. So basically the x, y, and z rotations. And here if you see in the vector 3, for the x, y, and z, we are basically taking 0 and then basically half and half for the x and y. Now lastly, camera dot current equals to true because there could be more cameras also. We want to set this camera as the current camera and add child and a camera. Now, whenever we are running the script, there should be a camera present. So let me run once again, and we see something very dark, but we do see some cylinder-like thing here. So something is cooking up, but we are yet to be sure what it is. Now, the reason it is very dark is because our scene does not have a light. Now, if you have used a software called Blender, which is a 3D modeling software, you know this concept very well. That in any 3D scene, we will need a camera, we will also need a light, and then some models. And only when they are perfectly placed, we will have a beautiful render. Now, if you have used 3JS, there is also a very similar concept. And so no surprises in Godot also, we will need a camera and a light. Now, for the light, what we will do is we will add a sun. So Here we have an environment and a sun, and we need to add both in our scene. So we will add a sun. We got a directional light 3D. So this is our sun, and then we will also add our environment. And so right now, however you see the scene, this is actually what the sunlight will give us. So now if we run, we will have a much better view. So as you can see, we have a plane, we have a box, and we have a cylinder. We can make it better, of course, but this is good for now. So we are getting some sort of an idea what we have because of our sun and our environment. Now we will keep these things as it is. We will go back to our script and we will do the more important part, and that is how we can create our floor and our maps. So in our create floor, we have to set a floor mesh. This will be a plane mesh dot new, and let's also give a size. So floor, not floor, mesh dot size. This will be a vector 2. Uh, the size will be whatever map size we have set. So map size dot x and map size dot y. Um, this is at the top. We have set vector 2 map size as 20, 20. So this is basically 20, 20. Now for our floor node, we will set mesh instance 3D dot new and floor node dot mesh. We will set our floor mesh, and let's give the floor node a name. The name will be platform, because this is where we will be standing on. Now let's also expand the coding space. Now after the floor node, we will create a floor body. This will be a static body 3D dot new, and we also have to add a collision. So why are we adding a static body? Now this is because this mesh and everything, they don't have any collision by default. Now whenever we add our capsule, which is our player, we want our player to collide with our mesh. So this is the reason we have to add a static body, which is important for adding collision. So we will do a floor collision equals to collision shape 3D dot new. Then we will have to give a floor shape for our collision. So floor shape will be box shape 3D dot new. Now what will be the size of our collision? Now in 2D you might remember that we add circles as collisions, and we also have to set the size of our circles, and this is exactly what we are doing here. So floor shape dot size, this will be a vector 3, and the size that I want to give is the plane size, and I just want to give a little bit of thickness. Otherwise, what is the meaning of collision? So map size dot x, for the thickness, I want to give, let's say, a 0.1. So this is for the y, and for our z, I will give a map size dot y. Now you might get a little bit confused that wherever we have a z, we are actually assigning the y, and wherever there is a y, I am assigning the thickness. So the last value is a z, but I am giving it a y. The reason is the map size I have defined as a vector 2. So this is x and a y. However, here it is a vector 3, and the z value, so if you see the direction in our map, the y is the top direction, the x and z are the horizontal directions. A little bit different from mathematics where the z is generally considered to be the altitude, but yeah, so this is what it is. So this is the reason we are setting the y value for the z, and this also happened above, I believe here. So as you can see, whenever we are setting the camera position, in the Z, we are setting the Y, and in the Y, we are setting the X. And for the X, we want a 0. So this 0 is basically wherever is the origin X, we want it there. So let me just remove it, and now we'll get a better idea. So X, Y, and Z. So X value is 0, And basically y and z value is a 10 10. This x by 2 and y by 2 really doesn't make much sense. So this is basically your altitude. We don't have an altitude. We can directly give 10. And this is the reason whenever we were viewing from our camera, we do see some height. And this is the reason for this, because here we have a 10 value and the y is also a 10. The y, this is not the y anyway. Even I am getting confused because of this orientation. So our camera is basically 10 over here and 10 at the top. So we are viewing from somewhere at this location towards this location. And that is how we are viewing it. Now to give you an idea, if I just make it 10, now we will get from a diagonal position. So you, as you can see, it has come here. So this is the basic idea of 3D orientations, but we will just keep it as it is for now. This suits us good. Now we have a floor shape dot size. Now we have to add a collision. So floor shape, not floor shape. We have a floor collision dot shape. We will assign the floor shape. Floor shape. Now we have to add all of them as a child of our node. So what I will do is first for the floor body, I will add a child, the floor collision. And then for the floor node, I will add a child, the floor body. Now we can add a material also. This is mostly for the color, but even without doing this, this will work perfectly fine. But this looks good, so we will add it. So standard material dot new. Then to change the color, we can write like this material dot albedo color. And here I want to give the background a slightly darker color, like it was in the intro. So color, we can give 0.3, comma 0.3, comma 0.3. So basically RGB values, and this will make it darker. Now in the floor node, to apply the color, we will write set surface override material, and we'll do 0, comma material. And lastly, in the map container, we will add the floor node as a child. Now it should work perfectly fine. So let me run our scene once again. And we have a problem. The problem is the function add child doesn't exist in base string in line number 51. So it is saying that the floor body or floor node, whichever, is a string. Oh, this does not exist in base string. That is true because we have mistakenly assigned the floor node as platform. We were trying to give the name of the floor node as a platform. So now it should work fine. Let's run again. And we have a darker platform. Previously, we were seeing a white platform. Now it is a dark platform. And that is because of this material. So now in my ready function, we have created the floor. Now we have to generate the map. Now generating the map means basically generating 15 boxes and 10 cylinders. So let's see how we can do this. So where is our generate map function? It is here. Let me take it below, or I think it is fine over here. So we will basically loop through our boxes and our cylinders and draw them one by one. So we'll write for I in range num boxes. We will do create box, and let me write it like this, box underscore plus stri. This is one kind of identification, like some kind of an ID of the box. So basically box underscore 1 2 3 4 5, it will do it like this. And then we will write another function. Let me expand the space. For 10 comes for I in range num cylinders, and we'll do create cylinder, and let me write it similarly, cylinder underscore plus str, I. Let me give this small letters like other functions. Now we are getting some sort of an error, and that is because these functions don't exist. So we have to write these functions. So func create underscore box, and we will have the box name or ID or whatever. This will be unique, no doubt about that. So we will have something like this. Then there will be another create cylinder name string pass. There is still an error over here because the B should be small, not a caps. Now, what we have to do inside the create box is basically create a box in the same way we have created a plane. Now, we have not really created a plane over here. We have used a box shape 3D. So this is also a box, but with a very small thickness. But here we have to create more solid boxes. And so how can we do that? We will follow the same approach. So let's start by creating a box mesh dot new. Now let's write a mesh instance, and this will be a mesh instance 3D dot new. And in the mesh instance dot mesh, I will assign the box mesh. Now the mesh instance can also have a name. I will name it mesh. That's all, mesh box. Now we have to create our box. So box will be a node 3D dot new. Then let's give a box name. This will be the name that I have taken in the function, basically box 1, 2, 3, 4, whatever. Then in the box dot add child, I will add the mesh instance. So a box is like a parent. Now the parent will have a mesh. It may have few other things like a static body, collision, etc., etc. And hence we, for the mesh instance, we are naming it as mesh box. And for our box, we are naming it as box 1, 2, 3, 4, whatever. And this part is basically similar for all the boxes. So even if something is common, it really doesn't matter. Then we have to add a static body for our collisions. So where static body, let's do a static body 3D dot new. Then collision shape. This will be collision shape 3D dot new. Now we have to add a box shape also. This will be box shape 3D dot new. For the collision shape dot shape, we will add the box shape, and then we have to add the children. So static body dot add child, we will add the collision shape, and for our mesh instance dot add child, I will add my static body. Now if I compare with our create floor, this is very similar. We are creating a floor mesh, then we are creating a floor node, then the body, collision, and shape. We are like assigning the shapes and collisions, and lastly adding them as children to our nodes. We are lastly adding a material, and then we are adding it in the map. So very similar things we have done over here. But there is one additional thing that we have to do, and that is we have to randomize the position. For our floor, we all know what is the position, somewhere near the center, but not so simple for our box because they will be randomly distributed all over X and Z. So let me add where pos X. So this will be rand f range, and the range will be, let's say, minus map size dot x divided by 2, and map size dot x divided by 2. So in between minus x and plus x, uh, like half of the minus x and plus x, and that will be our distribution of position x. And for the position of z, we will do the same for our y. Now again, why this is z and this is y? Because the map size is a vector too. Makes sense because even in 3D maps, we don't really count like how much altitude is there. We generally count how much length and width is there, like our own world. We don't count the altitude because we generally care about jumping, but not traveling upwards. Yeah. So this is how we got it. Now we remember that we have also added some scale. So whatever box or cylinder we add, they can be within the scale of 0.5 to 2. Like they can be half as small or twice as big. So we have to take care of the scale also. So after getting our positions, what we will do is we'll take scale factor, and this will again be rand f range of minimum scale and max scale. So we will get a value between zero point 0.5 and 2, and we will apply that scale. So box dot scale should be vector 3 of scale factor, comma scale factor, comma scale factor. We will only have boxes, we will not have cuboids or rectangles because in all x, y, and z, we are adding the same scale factor. But very easily, we can use rectangles also. Now this will be a very interesting map compared to what we saw in the intro. If we simply do an XYZ. So this will be an X, this will be a Y. I never thought about it, but yeah, I found this will be a very interesting thought experiment. Now let's also give a rotation dot Y rand F range of any rotation is fine. So in between 0 and 2 pi. 2 pi is the total one, and 0 is basically from where we are starting. And again, in all three directions, we can have it. Initially, I thought that the box orientation will change. That will look weird, but yeah, anyway, I think this is also fine. Now, lastly, let's add a material and let's add the boxes. So where material should be standard material 3D.new and material dot albedo color, and we have already randomized it. We will do it again. So randf, comma randf. Anyway, these values should be between 0 and 1, so this will be perfectly fine. Comma randf, and lastly mesh instance dot set surface override material 0 comma material. Lastly, in the map container, we will do the add child, and we can also do a return box. I think that may not be required. Let's see once. Yeah, anyway, it is not required. And for some reason, the map container add child, here we have to add the box. Now let me run the scene. And it is looking a bit strange because all boxes are for some reason being generated in a very small space. So what is really happening here? Let's try to understand. And the biggest issue is nowhere are we setting our box position, and that is why everything is kind of looking like is being spawned at the center. So after the scale, what I will do is we'll set a box position, and this will be a vector 3, but we have to set two values. So this will be our position x. Then for the y value, what I want to do is I will just give a value of 1, and for then we'll give the position z. Instead of 1, we can do something interesting, and that is where pos y, or we can do it at the top wherever we are declaring the positions. So where pos y, this will be rand f range, and let's give the position in between 0 and 10, and we'll give a pos y And as said before, this return box is not really required. So now if we run the scene once again, we will see all boxes scattered in so many different directions. I think the y value is really causing some problems. So instead of 0 and 10, I will give it 0 and 2. Now seems better. So we have a lot of boxes scattered everywhere. If we just increase the number of boxes from 15 to 25 maybe, we will have a lot more boxes. Yes. So anyway, whichever is a good number, we can take that. And now we also have lots of rectangular shaped boxes, and that is because the scales are different. This kind of looks better or worse than our original map. We don't know, but yeah, this is definitely fun. Now let's add our cylinders also. So for our cylinders, we'll follow the same approach. We'll start by creating a cylinder mesh. This will be cylinder mesh dot new, then mesh instance will be mesh instance 3D dot new, mesh instance dot mesh will assign the cylinder mesh this time, and mesh instance dot name, let's give cylinder mesh. Now we have to create the actual cylinder. So where cylinder will be node 3D dot new, cylinder name will be whatever name we are getting, cylinder 1 2 3 4 5. And then in the cylinder, I will add child and will add the mesh instance. Now let's add the static body and everything else for the collision. So static body will be static body 3D dot new, collision shape will be collision shape 3D dot new, and lastly we'll have a cylinder shape. So cylinder shape, this will be cylinder shape 3D dot new. Now what we have to do is after getting all of these things, we have to add them as children of our node. And before that, in the collision shape dot shape, we have to assign our cylinder shape. Now in the static body dot add a child, we'll add the collision shape, and in the mesh instance dot add child, we'll add the static body. Lastly, we have to randomize the position x and y and other things. We have to set the scale, and we have to add the material, and that's all. And better, I can simply just copy these things. There will be no difference at all. So I can just copy all of these things and paste it here. So we are taking the position x in between in the map, position y, and here there are lots of boxes. This should be changed to our cylinder, and that's all. Now lastly, we are setting the material and material. Now if we run the scene once again, we will have our scene with lots of boxes, and so there is a problem. And the problem is this: in the new collision shape 3D, we have to add a parenthesis. And another bigger problem is there, and that is for the box. We were doing the map container add child, but where is the add child for our cylinder? So we have to add that also. So not add child, and let's add the cylinder. Now let's run the code once again. And we have lots of boxes and lots of cylinders in different kinds of orientations. Now, a better way to generate the map would be before generating a cylinder and a box anywhere, we can check if there is already a cylinder or not. If yes, we will like spawn it in a different area. But going forward, as we are making more complex maps and more interesting applications, we can take care of that. For the time being, we can just live with it. So I will give 20 boxes and 10 cylinders. I think that is fine. And I think regarding the scale, it should be between zero point 0.5 and 1.5 rather than 2. I want things to be a little bit smaller. Now things look good. Now, in our 3D map, everything looks empty, which is correct because we have hidden everything. Now, if we have these things also, we will have little bit of an overlap. So, for example, this tall cylinder is here. Let's just remove them altogether because we are not using them. We are using a new map. Now, I have created a capsule, which is our player. Now, how to create a capsule and code our player? So, capsule is also a mesh. It also has a collision and it also has a script to move around. I will show that in a future video. But for now, I will just import my capsule in my random map. So from my scenes, wherever I have my capsule, let me just bring it over here and let's start the game once again and let's see. So there is little bit of a problem. We don't see our capsule. That is one of the problems. Uh, so I think the location is not correct. So let me just take our capsule a little bit above. And now if we run once again, we do see our capsule coming from the top and our capsule is also moving. But the direction of the movement looks very strange. So we are pressing W. It is kind of moving. It is kind of moving not in the right direction. And because I'm moving my mouse, the capsule movements are also getting changed. So this is so why is this problem happening? The problem is because the capsule has a camera. If you see carefully, the capsule also has a camera. So let me go closer. So this is the camera for the capsule. So it is trying to view the capsule from this angle. It is trying to view the capsule from this angle. Now in our 3D geometry map, we are creating another camera. So there is kind of a conflict of cameras. So that is a big reason. So what I can do is I can just stop creation of this camera and now we can see everything from the capsule point of view. So yes, so our capsule has come down. Now our capsule looks a little bit big compared to all our objects. Now that has a simple fix. So what we can do is in our map, in our random map, uh, in our scene, uh, wherever we have this capsule, so we'll select this capsule, we'll go to scale, and we want to shrink the size of the capsule. So let me make it much smaller. Now if we run once again, we have a small capsule and we have bigger boxes and cylinders. Now I don't know if this looks better or the scene at the start of the game that looks better, but this looks more dynamic, you can say. So there is gravity also. So we are kind of not able to stand still over here. And here are also many kinds of scenes. Now, if you can see, we don't have a mouse cursor and the mouse is being used to look around everywhere. So how can we close the game? We have to press escape. Then we'll get our cursor back and we can come to the corner and then close. So this is how the capsule is coded. So the capsule will take away the mouse cursor. Now this is our regular map that is being created when we are spawning the game. But for a randomizer, we have to make use of a randomize button that we had initially. So here what I will do is I will add a canvas layer. Then I will add a button. This should be at the top, let's say. Randomize. And for the button, I will add a signal pressed. And it should be for our 3D geometry map. So connect. We got our signal. So whenever we are clicking on the button, we want to do all of these things. Now, it's not all. There is little bit of a difference. And so what we will do is we definitely have to do the create floor and generate map. Now, apart from that, we need to check few things. And that is we already have some boxes and cylinders created. So we'll first check if map container exists. So then map container dot free. We basically want to free everything from the map container. And then assume we will have another map container, node 3d dot new, then map container dot name, map container or whatever it was, and then again add child map container. Now if we run the scene once again, we have everything that we had. Let's go back to one corner, and then if we press the randomize button, let's see what do we get. So we have different kinds of maps, and by the numbers it looks like the number of cubes and cylinders and everything is maintained, looks like that. So that is very simple. Now you can also add other shapes, for example cones, capsules, could be other random shapes that you have imported from Blender, and other things. And anyway, we will also be doing all of these things in the future videos. So I will also be showing you how to do the capsule and also many other things. So that's it for this video, folks. Now, if you have any doubts related to anything in this video or any other video for that matter, I have a Discord server. You can join over there and you can ask me anything that you need some help with. So either me or any other people from my channel will definitely help you. So that's it for this video, and I will see you soon with another very interesting video. So see ya.